Hello all. Now let's see the differences between multitasking and the multithreading. So if CPU executes or performs two or more tasks at a time, then we call it as multitasking. If the CPU performs or executes or runs two or more small subtasks, so these are very small generally when compared to the tasks, and these are also known as threads. So when CPU performs two or more small subtasks, we call it as multi-threading. Now let's see the examples for multitasking and multi-threading. So let's take our computer, and it has Windows OS, Windows 10. So the operating system simultaneously can perform more than one task. Like it can run browser and file manager and some editor. So these tasks are performed simultaneously by the OS. So this is called as multitasking. So coming to the multi-threading, if in the file manager we can perform deletions, copy, and open the file from the file manager. So these tasks can be performed simultaneously by the OS. Now this is called as multi-threading. Here in the same application we are doing the subtasks simultaneously. So this is called as multi-threading. And one more example for multi-threading is if you take our phone, we have many applications. Let's take WhatsApp in that. So uh, so we are chatting with one person, and simultaneously what we can do is we can send a photo for them which is loading, and we also type a message while the photo is loading, and also we can receive messages from them. So here receiving process is executing, uploading process is executing, sending process is also executing. Simultaneously in the background there may be a status or uploading, or you may uploading, or they may downloading uh, status, statuses. So this is called as multi-threading. So in the same phone, we can we can open WhatsApp and YouTube at a time. So this is called as multitasking. So this is how these two differ, and we also see how they differ in uh, technical terms. So if you consider the how they perform, how the computer or CPU performs multitasking and multi-threading, it means uh, uh, there are more than two tasks. So how CPU performs these tasks simultaneously? So what CPU does is, CPU or OS does is, it executes a process called context switch. Means by using some algorithms, CPU or OS can select a process. Like OS can select a process and executes it for 2 seconds, and for next 2 seconds next process, and next 2 seconds next process will be executed. So by this type of switches, we can achieve multitasking. Even for the multi-threadings, the same process will be executed for the switching between the threads. Switching between the threads. So some of the algorithm for context switching is uh, we can select the first process that comes as for the input for the OS. So the first process execute can be executed for some time, and then the second process can be executed, or they can be executed based on the priority. Like if there are any security issues or any payment apps, so these can be executed by the priority. So the priority is decided by the OS generally for the OS processes. Multitasking and multi-threading. So generally in the multitasking, for every process there will be separate memory allocated. So for this particular task T1, there will be M1 memory allocated. For the process T2, M2 memory will be allocated. So there will be no conflicts, like T1 does not access memory M2, and T2 does not access memory M1. So there is no conflict and they can execute without any conflicts. So coming to the multitasking, so coming to the multi-threading, as there are subtasks in the same task, call it as task T1. So memory M1. So all these subtasks only have the same memory and have the same resources. Resources means if they want any other information to execute, like opening a file, reading from a file, all these type of tasks, we need some files like or mouse, if you want any inputs, keyboards, or else printer. So these are called as resources. So these all subtasks have access to these files, mouse, keyboards on these resources, same set of resources and same set of memory. So there can be conflict, like one the same through two threads can access the same memory uh, point. So this might lead to some problems. So let's see what they are. Like this is memory and it's stored in T equal to 10. So this is the thread T1 in the task 1. This is the thread T1 and this is the thread T2. So the task of T1 is to increase A. The task of T2 is decrease A. So after performing the task 1, what should be done is the A value doesn't change, like one time we increase and one time we decrease, that's it, right? So A should be 10 after performing the task 1. So let's see what happens if the T1 and T2 executes simultaneously. So first A A plus plus, it takes the value of 10, and T2 also takes the value of 10. So what will this become? 11. So and what will this become? 9. So the perform here the operation is done, so it has to update in the memory. So we don't know which one updates first. Either a thread T1 can update or T2 can update. So if T1 will update the memory, then the value will be 11. Otherwise, it will be 9, which is if T1 executes and updates the A value, then the value will be 9, as the T2 will be executed the execute second. So what generally will be done is A plus plus is there. A is 10 in the memory. So this is T1, this is T2. A minus minus. So if first A plus plus is done, then A will be 11, and after executing the TT, A will be 10. So after executing the task, there will be no change in the value A. But if we run the task simultaneously, then there is a problem. Like we may get 11, 9, 10. We can get any of these values, right? So what are the cases of getting 11, 9, 10? Let's see clearly. So if T1 access the value A first and increase, it will goes 11, and T2 access the same A, it goes 9. So if T2 updates the value first, then it will be 9. After T2, then T1 will updates the value to 11. So this is the case of coming output as 11. So let's see the case of 10. So this is the general case. What should the process that we want? So first T1 will access A and increments to 11 and updates the value in the memory, which is 11. Now T2 access this 11 for A and decreases 1, so which is 10. Now we will get 10. So let's see the case for 9. So T1 can access A first, which is 11. T2 can access next, which is again 9. So after this, first T1 can update its value, which is 11. After that, T2 will update the value to 9. So we can get any of these outputs. So to avoid this conflict, there are some concepts like locks, synchronization. So by using these concepts in Java, we can make these conflicts clear. So in the next video, we'll see about how we can execute without conflicts in the multi-threading and multi-threading in general Java, and also the multitasking.